Hey guys, welcome back to our channel Get Placed Soon. In this video, we are going to solve a very standard greedy algorithms problem, fractional knapsack. First, before solving the problem, let's understand the problem statement. Fractional knapsack problem, you will have a limited capacity knapsack. Okay, knapsack is nothing but a bag like thing where you can store items. So that knapsack will be of limited capacity. And we are also given a set of items with its weights and values. It may be value, it may be a profit, it may be anything. Okay, we will be given two things. One is knapsack capacity and items weights and items profits. Now the goal is to maximize the total value of the items you can fit into the knapsack. You can take fractions of items if necessary. Generally, in knapsack problems, there are two types. One is fractional knapsack, where you can take fraction of items. For example, if you can't take the whole watermelon, you can take whole 1 kg watermelon, you can take half kg watermelon. Like half piece you can take, a fraction of that you can take. Another type knapsack is known as 0-1 knapsack, where you cannot take any fraction of items. You take it whole or you don't take it. That's it. Here we are using fractional knapsack. And the fourth point is by selecting items based on their value to weight ratio, starting from the highest ratio, you can achieve the maximum value within the knapsack capacity. This is how fractional knapsack works. If you don't understand the fourth statement, don't worry. We'll look at the examples and get back to the fourth point again. Now, consider in the right side we have a knapsack, that is a bag which can hold until 7 kg. Now, we have three items with us: watermelon, pineapple, and mango. The weight of the watermelon is 4 kg and value is $8. Weight of pineapple is 3 kg and value is $6. Weight of mango is 2 kg and the value is $5. Now, we have to do fractional knapsack. What is fractional knapsack? Look at the second point. Maximize the total value of items you can fit into the knapsack. Total value in terms of dollars, total value of items you can fit into the 7 kg knapsack. Now let's get started. The first step is to calculate the value to weight ratio. So value divided by weight. 8 by 4 gives you 2 per kg. So what is the value per weight ratio of watermelon is $2 per kg. For pineapple it's $2 per kg. 6 by 3. For mango it is 5 by 2, that is $2.5 per kg. Now sorting them in the order of highest value per weight ratio. What happens here is the first thing, highest thing, that is mango, $2.5 per kg. Now, watermelon and pineapple both are having equal. Generally, when two items have the same value to weight ratio in the fractional knapsack problem, you can choose either of them first. The choice is yours. But here, I would like to take pineapple second and watermelon third, because the weight of pineapple is less than weight of watermelon. Now let's give the rating like mango is first, second pineapple, third watermelon. So we already know it's 7 kg knapsack and the mango weight is 2 kg. We can fit 2 kg in 7 kg, right? So just placing mango in the knapsack. Now how much is the remaining capacity of knapsack? 7 minus 2, that is 5 kg. We have added the whole mango, so whole value is $5 till now. Now moving ahead, adding pineapple. Pineapple is 3 kg and we already have 5 kg left, right? 5 minus 3, now only 2 kg is left in the knapsack. Pineapple is 3 kg and we can fit till 5 kg in the knapsack. So adding pineapple to the knapsack. Now 5 minus 3, 2 kg is still left in the knapsack. Now whole pineapple is added, right? So the value will be $6 of pineapple plus $5 of mango. The total value till now is $11. Balance space in the knapsack is 2 kg. You can see in the right side. Now in the 2 kg, can we add 4 kg watermelon? No, we cannot add 4 kg watermelon in 2 kg because it will not fit. But just because it's a fractional knapsack, we can add a fraction of watermelon. If it is a 0-1 knapsack, you cannot add fraction. You will just stop here. You will not at all touch watermelon. This is fractional knapsack. You can take a fraction of the watermelon. Now, to calculate the fraction of the watermelon, you have to divide remaining capacity by watermelon weight. Remaining 2 kg you can fit in the knapsack and 4 kg is the watermelon. That gives 0.5. Now you can add 0.5 kg of watermelon to our knapsack. Now what will be the value? 0.5 kg, 0.5 into value of watermelon, that is 8. Now the total value will be $5 of mango plus $6 of pineapple plus 8 into 0.5 of watermelon, that equals $14. So the maximum value you can add into 7 kg knapsack is $14. So what all we added? We added a fraction of watermelon, that is 0.5 kg of watermelon, and 2 kgs of mango, and 3 kgs of pineapple. And in the 7 kg knapsack, you got $14. Okay, the code looks huge, but don't worry, I'll go and explain snippet by snippet wise. Now, first look at the main function part. In the main function, you can see we are creating an array of items. We have three items here with the weight and values, right? But how are we creating these items? We are creating this item by creating an object, right? We are creating this item with the help of this object. And how are we doing this? From this part. So this is a static class item. So this is a static class where two instance variables are there. One is profit and one is weight. After that, you can see we have a constructor, this dot profit, this dot weight. Why are we doing this? Because we have different items like watermelon, pineapple, mango, and each item have different weights and different values. So to refer to watermelon and to get that profit, to get that weight, it is difficult. To make things easy, we are creating a constructor. After that, you can see two things. One is get profit and get weight. So if I want mango's weight or watermelon's profit, I can access them, I can get that info by using these methods get profit and get weight. So this is how class item is defined. From that, we have written in the main function three items with the value 6, 3, 5, 2 and 8, 4. Now getting back to the main function continuation, we are giving int capacity is equals to 7. That is the total knapsack value. After that, we are passing the items and the capacity. Items are like watermelon, mango, pineapple, and the capacity, that is knapsack capacity 7 kg. We are passing this into the get max value function. In the left side, you can see that function get max value. Now let's dive into this function. Now here in this part of the code get max value, you can see we are using arrays.sort. In this arrays.sort, you can see we are using comparator. So this effect sorts the item array in the descending order based on the profit to weight ratio of the item. Now you can see the comparator method of the comparator interface is overridden to defining the comparison logic. The items are considered based on the ratio of profit to weight. Higher ratios come first, so the items with higher values are prioritized in the knapsack. Okay, you can just see double item 1 dot get profit divided by item 1 dot get weight again, and another ratio of another item. Now comparing these two items. So this array dot sort will do in the descending order. It takes two items, it will compare, and finally it will sort all the items. Moving ahead, here this line declares a double variable name total value, and it is actually initialized to 0. Now coming to the last part. This is the very important part of the code because every step of the fractional knapsack is done by this. This loop iterates through each and every object in the items array. It checks if the current capacity minus weight of the items is non-negative. If it is non-negative, that item can be added to the knapsack entirely. The capacity is reduced by the weight and the total value is increased by the profit of the item. If the capacity is not enough to add the entire item, a fraction of it is added. Okay. The fraction is calculating by dividing the remaining capacity by the weight of the item. The total value is increased accordingly and the capacity is updated. This loop breaks after processing the last item or when the capacity is exhausted. There are two times when these loops will stop. One, if all items are done, if we added all the items, or second, if the capacity is completed. And finally, we will return the total value. I hope you understand. Now, discussing the time and space complexity. Speaking of time complexity, the sorting part. Here we are sorting in the descending order in the ratio of profit to weight, right? So the time consuming operation is the sorting. Arrays.sort. It takes O of n log n, where n is the number of items in the array. After that, again we are in the for loop iterating the array O of 1 O of n times, where n is the number of items. But overall, the time complexity will be O of n log n. Now, speaking about the space complexity, each item in the array requires a constant amount of space. We are using it. That's why the space complexity of the array is O of n. So that's it from my side. I hope you understood the video. If you have any doubts, feel free to comment below. Thank you so much for watching till the end. Please like, share, and subscribe to our channel. Get placed soon. Thank you.